I'm going to do a role switch. And it's now my honor and my pleasure to introduce Professor Gabriella Vigliocco. So what a better way of starting an interdisciplinary conference with a truly interdisciplinary researcher. Just some background. Professor Gabriella Vigliocco is a professor of the psychology of language at the Department of Experimental Psychology at UCL, the University College London. And she boasts many accomplishments throughout her career, just highlighting some recent ones. For example, she's the director of the Leverhulme Doctoral Training Program for the study of the ecological brain. And she has received an ESC Advanced Grant on Ecological Language, which is also related to the topic of her talk. She's currently the Royal Society Wolfson Research Merit Award holder. Now, when it comes to the research, one of the things that's really exciting about Professor Vigliocco's work is that she's been at the forefront of embodied cognition research. She's always thought about language in a wider sense. That also means going beyond the spoken and written language, including not just including things like gesture and signed languages. And she's made great contributions on iconicity research, on the representation of abstract concepts, on how lexical semantics relate to emotion, and many other topics. And so with this, I'm so happy that we have you here, Gabriella. I actually have popcorn prepared. It's very early, but since it's going to be an exciting talk, I'm looking forward to it. I'm handing over to you.
Morning, everyone. I never thought of keynote lectures at conferences as a cinematic opportunity, but you know, that seems very fair given the situation. I cannot share screen. Disabled. Oh, no, now I can. Perfect. Thank you. Okay, so first of all, thank you very much. As I was telling Bodo before, it's really strange to be here, all dressed up as I would be if I were to give this talk to you face to face, but then with my bare feet in Crocs, because of course you're not seeing my feet. Okay, so what I'm going to do today is to present some work that we are doing right now. Therefore, it's in progress in many ways, but I believe it gives you a sense of where I believe certainly my work is going, and I believe the field could benefit from having more of. Okay, now let me just start in this way, but just presenting a little bit of a cartoon. Now, I believe we all agree that language cannot have originated as hominid, coming up with linguistic symbols that are then transmitted to other hominids. Rather, language must have originated because of the need for sharing information among hominids occupying the same territory. Likewise, children do not learn language on their own as a set of linguistic abstract symbols. They don't learn language just by listening to others speaking. Rather, they learn language in interaction with their caregivers. And although we adults can certainly deal with abstract linguistic symbols, and we may even enjoy very much dealing with them, as in reading, still, I would argue our primary and our favorite form of communication is face-to-face. And for example, in fact, for this reason, we have developed technologies that allow us to carry out communication in a way that is as close to face-to-face as possible. And by the way, this, as we're all very, very aware of, very well aware of those now during the pandemic. Okay, so what is the take-home message here? Is the point that language has evolved, is learned, and for the most part is used in face-to-face interactions. Yet, and I've been guilty of this sin for many years, we study it only as speech or text, or if you're focusing on sign language, for example, primarily focusing on the manual component of science. But what I'd argue today is that understanding language development, processing, and its neural circuitry requires understanding how children and adults use the communicative context, namely the multimodal information that is available in face-to-face communication. And what I'm going to do is to introduce to you what I've been labeling the ecological language approach to the study of language, according to which, first of all, language, I'm looking at language as communication, as unfolding in real time in a face-to-face setting, when multiple multimodal cues are available. And I'm going to tell you in a second what are the multimodal cues on which we are focusing on. Language is situated. Language is, if we're talking about the here and now, language is situated into the physical context in which the conversation is taking place, but it's also situated in the communicative context between the interacting partners. If we're talking about something that is displaced in time, in space, language is still situated. It is situated in the communicative context. Moreover, language learning and language processing are intertwined. They're not fully separable. Okay, so these are some basic principles of our overarching approach. Now, let me tell you about the multimodal cues that we in our work begin to focus on. Well, first of all, by the way, the talk is all on spoken language. The speech is one of such cues, and these provide linguistic content as well as discourse context. Of course, we have prosodic modulation is another of these cues. And here, for example, we have changes in pitch, intensity, and duration. Vocalizations are another multimodal cue, and we have focused primarily on sound effects being lexicalized in the form of onomatopoeias like meow, meow, woof, woof, or sound effects. Mouth movements, these are the movements of the lips and of the mouth that necessarily correlate with speaking. We have gestures, hand movement that can be related to what is being said in meaning. These are, we are referring to those here as representational gestures. They can index some reference in the real world, or they can have they can be different, like bits, marking the rhythm of the speech. Also, another potential multimodal cue is that we refer to it as object manipulations, the fact that speakers can hold and manipulate things while they are talking, and of course, eye gaze. Speakers can look at what they are talking about. Now, a lot of studies in the literature looked at individual non-speech cue and what is their impact on language learning on the one hand, or language processing. But what is missing, I think, is the fact that they haven't been looking at this in the real world, and they haven't been looking at this they haven't been looking at this in the real world. And in the real world, these different cues co-occur. And so you need to look at all of them in order to get a sense of how they are distributed. Okay, so this is my spiel. Now, what is the plan for the rest of the talk? I'm going to give you two examples of how you can take this approach and implement it, and see what kind of conclusion we can draw from it. The first part, I will focus on the input to the children. And I'll ask the question of whether caregivers provide multimodal cues to children learning language. I'll move then to, in part two, to focus at more adult language processing. And here I'm going to be looking at, asking the question of what are the electrophysiological signatures of processing multimodal cues. So let's start from looking at multimodal cues and language learning. And here is the team of absolutely stellar early career researchers, or at least early career researchers when they did work with us. that have actually done the work that I'm talking about. And these are Beata Gazub, Yasamin Motamedi Yangu, who are currently postdoctoral fellow in my lab, Ricarda Brieke, Victor Kawanig, who are PhD students, Margherita Murgiano, who's an alumna who's now back in Italy, and Pamela Pernis, who's alumna as well, who's now professor in Cologne. Okay, here you have a typical toddler in a typical toddler room. Now, if we are thinking about how children learn, what words refer to, this is a pretty tricky problem. So suppose that mom comes into the room and says, "Bring me the elephant, please." Now, if the child doesn't know what an elephant is and doesn't know what other objects are scattered around are, then really it's pretty difficult for the child to know what the referent is. In other words, there's an important challenge of referential ambiguity. This is an issue that has been well described and very much researched in the literature. There's another challenge as well, though. Suppose that dad now comes in and asks, "Shall we go find a turtle outside?" Well, now this is seems like even a harder problem because the turtle isn't even there. And if the child doesn't know what a turtle is, then of course it's really difficult for the child to link the label to a referent. I'm labeling this as the challenge of displaced learning. Now, although I don't have any actual estimate of how often displaced language is used with children, it seems like a very common occurrences, like for example, when a caregiver say, "Let's go and see grandma in the other room," or when a caregiver refers to the merry-go-round that had been seen in the park the year before, for example. Now, there have been a lot of work in the literature, in fact, that have addressed these issues. Here I have a very idiosyncratic, very incomplete list of hypotheses that have been put forward to account for the challenge of referential ambiguity of displaced learning, or both. Now, I'm not going to go through any of these positions, but I just want to make 2 points from these slides. The first point is that indeed, in the literature, there's much more, many more hypotheses dealing with the challenge of referential ambiguity than the challenge of displaced learning that has been kind of neglected to some important extent. Also, if you look at those theoretical proposals that in a sense can be used to account for both, these or a number of these focus on what the child brings to the game. So on the cognitive or social processes that the child implement in order to be able to deal with these challenges. The problem I have with this is that actually caregivers provide rich multimodal, non-arbitrary input to their children. And they can, for example, use points to help the child dealing with the challenge of referential ambiguity, or also manipulate the objects that are present in the scene, again, to make the referent unambiguous. They can also use other cues like prosody, the use of onomatopoeia, or the use of gesture when the objects are not there. So for example, a mom can modulate the prosody by saying "going up," while at the same time raising up the child to help the child mapping the movement up with the caregiver is saying. The caregivers can use onomatopoeias in order to help the child map between the labels that are being produced and the noise that the animal makes. Or they can use representational gestures, like in the case of the picture there of a dad indicating a pinch of salt, in order to bring to the mind's eye properties of the referent. Now, the each of these cues have been investigated separately by different researchers. What we are doing here is to ask whether caregivers use these multimodal, non-arbitrary cues, any of those, especially when they are most useful to the child. And what do I mean? It will become clear in a second what I mean most useful. So in order to do this, what we have started doing is to collect a corpus that we have labeled the Ecolanguage corpus of conversation between a caregiver and their child, and the children are between 2 to 4 years old. And this is all families that speak British or American English. The diets are being recorded, in fact, densely recorded in their home, and while they are sitting around the table, talking about objects that we provide to them. And they talk about sets of objects, for example, animals here, some of which are familiar, known to the child, as the pig, the horse, and the panda here, and some of which they are unknown to the child. And this allows us to kind of spot, to highlight, to separate clear learning episodes during the communication. Also, they talk about these objects while the objects are there, present in front of their eyes, as well as when we remove the objects, they continue to talk about them. And we do this in order to be able to tap both into the use of language in the here and now, as well as displaced language. Okay, so here are the cues we are primarily focusing on. We distinguish between indexical cues. These are cues that are used when the objects are present, like point to the objects, manipulating the objects itself while talking about it, or looking at the objects. And we would argue that these can be especially useful in sorting out the challenge of referential ambiguity, because they help singling out reference. The other cues we are focusing on are iconic cues. These can be used both when the objects are present as well as when they are absent. And these are things like onomatopoeia, representational gestures, like a dead deer making a scooping action to pick up something, or iconic prosody as the mom deer highlighting the long legs of the flamingo, elongating the vowels in the word long. And we argued that these iconic cues would be especially useful in the case of displaced learning, because they bring the reference to the mind's eye. So what we are doing in this work is indeed to look at communication in 4 main types of contexts: when the object is present, when the object is absent, when the object is known, and when it is unknown. And the question I'm going to address today are whether caregivers use more cues in learning contexts, also whether caregivers use more iconic cues in displaced contexts, and whether there is a developmental trajectory. Okay, so here's just some examples of the set of objects that we have used in this work. And here I'd like to give you a couple of examples of the type of interactions we are capturing here. I'm going to do the same dyad. First, here you see them talking about foods with the object there in front of them, and then you'll see them talking about foods without the object in front of them.
It is on the barbecue. That was on leeks, wasn't it? And what did we do with the parsley?
Well, then they can go on the barbecue.
That could go on the barbecue, yeah.
And
Can the grapes go on the barbecue?
yeah.
Oh, they're fruit. That's going in our fruit salad, isn't it?
Right, little girl is not yet on her way to become a chef, but here's without the objects.
How do we cook our sausages?
With a pan.
You can, yes. You get them out of the fridge. We're going to put them on the grill.
Yeah.
Yeah?
So we have
Turn the oven on. And the sausages are nice and long, aren't they?
So we
Nice
have,
long sausage.
look, so we have a barbecue here.
Oh, that's right. We cook sausages on the barbecue, don't we?
So we have a barbecue here.
Okay. Let's do a real barbecue. Okay, so let's get.
Okay, so as you see, just very normal, naturalistic style interaction between a caregiver and their child. Coding. So for each diet, we have about 20-25 minutes of video. And what we do is to chop it into utterances. So to mark utterances, these represent units representing an event. For each utterance, we note the topic, namely what object is being talked about, and we note every time the label is being used. Then we code for our iconic and indexical cues, onomatopoeia, iconic prosody, representational gestures. We code for the use of points, object manipulation, and eye gaze. And we've been using a bit of a mixture of different methods in order to do the coding, using some automatic annotation, some crowdsourcing, and a lot, unfortunately, of manual coding. Okay, so let me start first of all by showing you for the 60 children that we have coded so far, how often caregivers use labels when they speak. So what you have here is on the y-axis, you have the number of utterances that contain a label, namely the name of one of the toys, over the total number of utterances for that condition. Now, and you have the two panels, one for the 2 to 3 years old children and one for the 3 to 4 years old children. Well, as you see, there's a lot of variability, no surprise with that. Interestingly, you see that indeed the caregiver use the label more often when the object is not there, presumably because they can hold it, because they can point at it when it's there. But also, and interestingly, and perhaps surprisingly, they do tend to use the label more often for known rather than unknown objects. And the number of labels used tend to decrease. So I think it's interesting to see that they use the label more often for known than unknown objects. To us, actually, this is quite reassuring because it suggests that they are not taking our telling them to talk about these objects as a teaching game. They're not there trying to teach these new labels to their children. They're doing it in a more natural sort of way, which is reassuring with respect to representability of what we get with respect to everyday language use. Okay, now let's move to look at the distribution of our indexical cues. Right, so here I have, let's start with the manual one, the point and the object manipulation. Just as in the previous slide, the y-axis here represents the number of utterances that contain a cue, in this case, either point or object manipulation, over the total number of utterances. Now, a first thing to note here is that, well, we do not see very many points, although they are not a negligible amount. Whereas instead we see a lot of object manipulation. Well, we think that this is very much just due to the affordances of the tabletop situation that we used in the study. Namely, the objects are so close to both the caregiver and the child that it's much easier to get them and to grab them and to hold them while you're talking about it, rather than pointing them. If we look for both type of cues, how they are distributed, we see that they have a very similar distribution. First of all, they are more common for unknown rather than known reference. And in both cases, they are more common for older than younger children. So, as we were saying before, they tend to be used more often when they are more useful. That is, when the referent is unknown. We see a similar pattern when we look at the eye gaze. And here your dependent measure is how long caregivers have been looking very simply to the known versus unknown objects. And we see that caregivers tend to look longer to the unknown indeed, rather than the known. If we look at the iconic cues, which, as I mentioned before, I'd argue are important because they can bring the referent to the mind's eye. Here we have a somewhat different pattern. So if we look at onomatopoeias, we see that these are overall more common for referents that are unknown to the child, but this is the case only when they are absent. Moreover, what we see is that they decrease in, during development. So if you look at the second panel, you see that there are far fewer in occurrence than, especially in the first part, than in the first panel. If we consider then representational gestures, here's what we get. We have that representational gestures, just like onomatopoeia, are more common for unknown, the orange violin thingy, rather than known reference. But they are also, in this case, representational gestures are so much more common when the referent is absent in comparison to when it is present. When the referent is present, we see instead the object manipulations. And just like object manipulation, but in contrast to onomatopoeias, we see that representational gesture increase with the age of the child. Moving then to iconic cues, like iconic prosody, what we see is that also we have a similar pattern as we have seen before. First of all, I'd like to point out iconic prosody is quite rare. It's not used as often as the other cues. But if you look at the plot below, what you see very clearly is that caregivers do not use much iconic prosody at all for known reference. But they tend to use quite a bit of it when it is most useful again, namely when the referent is unknown and it is absent. There's also a very clear developmental trends here. And if you want to know more about iconic prosody, you should go and see Victor's presentation on Wednesday. Okay, let me give you a couple more examples to get you a feel of how these different cues look like.
You know what this is? This is an ostrich.
Okay.
Yeah, an ostrich is going to run very, very fast. Very fast. And they can go.
This diet had a really good time doing the task. And here it comes without the objects.
So the parrot goes. and at the bottom of his cage there's a little hedgehog snuffling around, looking for some milk and bread.
Okay, so what we see then across our data is that not arbitrary cues in child-directed language are quite well represented. And in fact, we have that about 40% of the utterances have indexical cues and about 17% of iconic cues. Crucially, they are differentially distributed. We see that indexical cues indeed are more common for unknown and they increase with age. Iconic cues, we see that they are more common for unknown, and in this case, absent as well. Then we see that onomatopoeias decrease with age, but iconic gesture and prosody instead increase with age. One possible way to account for why this difference for the developmental trend between onomatopoeia on one hand and iconic gesture and prosody on the other is that onomatopoeia represents a simpler mapping that can be understood, in fact, can be used by much younger children because it's unimodal, it's sound to sound. But instead, when it comes to iconic prosody and gesture, these embed far more complex and far more abstract mapping. So if you take, for example, iconic prosody, I mean, this is embedding notions like concepts like duration, direction. These are rather abstract things that perhaps require more sophisticated representational system. And again, if you want to hear more about onomatopoeia and about iconic prosody, Yasamin has a talk on Tuesday at 12, and Victor has a talk on Wednesday at 2:30. So what we have seen is that the indexical and iconic cues are available to the child and can support language development by referential disambiguation and displaced learning. What we also see overall, though, is that these non-arbitrary cues are very common, both in learning episodes when the object is new, but also in so-called processing episodes when the object is known, suggesting that they do have a broad supporting role. Now, what we haven't done as much yet, we're beginning to get in there now, is asking the question of to what extent these cues predict learning or vocabulary. Learning in general, and more specifically vocabulary. And for onomatopoeia, we can answer yes, or at least in part, and go to Yasamin's talk on Tuesday to hear more about it. Also, we can answer yes to some extent for with respect to prosody, and Jessie, she has a talk also on Tuesday, right before Yasamin's talk, that presents some results in that respect. What I want to do next instead is to move to ask the question of the role of multimodal cues and language comprehension. And this is work that has been carried out for the most by my PhD student, Ye Chen, and also with the help of Diego Frassinelli, an early career researcher who has been visiting quite often our laboratory in London, and who is in Germany, in Constance right now, as a junior professor. Okay, so we know from a long time that difficulty in predicting or integrating, depending upon your theoretical perspective, a word in previous linguistic context has a very specific EEG marker. That is a negative deflection in the EEG that peaks around 400 milliseconds from the beginning of the word, and is referred in the literature as N400. You see an enhancement of the N400 anytime while reading, for example, you encounter a word that doesn't fit the previous context. The N400, however, is not specific to language. And for example, it has been shown that seeing a speaker producing representational gestures that are incongruent with what is being said cause an enhancement in the N400. An effect on N400 has also been shown for big gestures, where the presence of big gesture has been associated in this case with a decrease in the N400 amplitude. Also, the lack of stress for new information, the lack of prosodic stress for new information causes an increase in N400, indicating that, so if you don't have stress for new information, this would be incongruent or mismatching information, just as we saw for the representational gestures, and this increases the N400. With respect to mouth movement, these have early effect on the EEG, compatible with their sensory role in language, but also they've been shown as showing an effect, an interaction with sentence context in the N400 time window as well. So the point I want to make here is that, perhaps given all this, perhaps the N400 is a good bet for finding out how the different cues interact. This time window may be the place where we want to look. in terms of interactions between the different cues. And the way in which we went about doing this is starting from this idea, that is, we are looking at the effects on the N400 of having more or less matching linguistic context. And then on the specific word, what we are looking is whether there's an impact and modulation of the N400 due to any of the multimodal cues. Okay, so here's what we did. We selected more than 100 short passages from a naturalistic corpus, the British National Corpus, and we had an actress acting them aloud. And here are a couple of examples of the short passages that we used.
Add the taco sauce, olive oil and spring onions, garnish with lime slices and serve piled up.
And another one.
Close the door and block any gaps around it with items of clothing. Then open the window and call for help.
Okay, so we had a participant then just sitting in a chair while their EEG was recorded, that what they were watching this video clip and answering comprehension questions once in a while. What is crucial here is that for each content word in these short passages, what we did is that we computed measures of linguistic predictability, gesture, prosody, and mouth movements. And let me show you how we did that. With respect to linguistic predictability, namely how predictable a given word is in a given context, linguistic context, we used a measure coming from computational linguistics, referred as surprisal. And this is the measure of the probability, indeed, of a word given the preceding linguistic context. We computed surprisal for our work on the basis of language models that are incredibly simple, but the results do not change using more sophisticated language models. And these language models were trained on a very large corpora. And here I'm just giving you an example, given one of our passages, of what these values would look like. Now, the reason why we use surprisal is because some time ago, Stéphane Franck, while he was a Marie Curie fellow in my laboratory, found that indeed words that have higher surprisal show an increase in negativity around 400 milliseconds in the ERP. So in other words, surprisal, we showed at that point that surprisal was a good measure of linguistic predictability as measured using EEG. But crucially, there's a big jump here. What we did at the time excuse me, was to look at reading, and in particular, reading one word at a time presented at the center of the computer screen, which is very far from being ecologically valid and very different from showing people audiovisual stimuli of the type we have. With respect to the other cues, the multimodal cues, here's what we did. For the representational gesture, we noted the presence absence with respect to their lexical affiliates. With respect to the gestures, also we noted their presence absence. We looked at pitch, and in particular, min F0 with respect to the prosodic modulation. By the way, we looked at min F0, but the results are very much the same using other measures like min, max, and so forth. Again, for each content words. Then we looked at mouth movements. And with respect to mouth movements, we came up with a measure of informativeness of the mouth. And in this case was the accuracy in a task in which subjects were shown a face like here, no audio, and they had to choose the word being spoken among alternative ones. And there you go. The word is chopping, if you didn't get it. Okay, so for each item, for each short passages in our study, what we do have is a measure of the linguistic context, mouth movement, prosody, representational gesture, and beat gestures. So first of all, what we do indeed is we wanted to see what is the time windows where linguistic context is having an impact. So first of all, what we did analysis in order to isolate the time windows where surprisal has an effect. And we did this using hierarchical linear modeling, where you're looking moment by moment for your EEG signal, where indeed surprisal has a significant effect. And we see that this is the case between 300 and 600 milliseconds, which is indeed compatible with the N400. Also, we see that this effect is compatible with the N400, also in terms of scalp distribution. It is especially centrally distributed and distributed to the right. So this is where we are looking for effects of our multimodal cues. What we did next was to carry out a linear mixed effect regression, where our dependent variable is the EEG signal within this time window, where we enter all of our multimodal cues and their interactions, and a number of other control variables that are, of course, necessary. And what I'm going to do next is to show you a number of graphs going relatively quickly, but I'll try to guide you through, that show the different effects. So let's start from the effect of representational gesture. But first of all, let me just orient you with respect to the graphs. I've always, for any effect I'll show, I'll illustrate it using two graphs. One is the EEG plot, and that's the one to the left, and also the R plot. The reason why I'm showing them both because different people have different preferences for one or the other display mode. Then on your y-axis, what you have is the amplitude of the EEG signal. The more negative the signal is, the larger the N400. The more positive the signal is, the smaller or more reduced the N400 is. Increased N400, we are taking it to indicate difficulties in integrating the new word into what is being said or in predicting it. Decrease N400, it means that the word is integrated more easily. Now, when it comes to representational gestures, first of all, we see that gestures have a global effect, a general effect, such that overall, when there are representational gestures, the signal is more positive. Crucially, we see that representational gesture interact with surprisal, such that the signal is especially negative for words that are high in surprisal, and therefore they are not very predictable in the linguistic context, but they are without representational gestures. When there are representational gestures, even for those words that are not as easily integrated in the context on the base of the linguistic information alone, the signal is much more positive, suggesting that it's easier to integrate them. Or in other words, what we see is that representational gestures support the processing. They make words that are less predictable based on prior linguistic context easier to process. We have exactly the same effect when it comes to pitch, mean of 0. Overall, words that have higher pitch induce a more positive signal, therefore the inference is they're easier to predict and to process. Words that have lower F0 are more difficult. And crucially, just like gesture, we have an interaction with surprisal, such that words that have high surprisal and therefore they are difficult to predict, and they have high F0 are easier to process than words that have low F0 and they are low predictability. So for higher pitch, we see that it supports processing by making predictable words easier to process. Pitch doesn't interact only with linguistic context, with surprisal. It does interact also with other cues. And in particular, what we do see, and this is the panel C above, is that it interacts with mouth movements. And here specifically, we see that there is a greater effect. There is an effect a positive effect of how informative the mouth movement is when there's higher pitch. Also, we see that pitch interacts with representational gestures, such that the facilitatory effect of representational gesture is larger when the pitch is larger. In contrast to these pretty large effects of representational gestures and pitch, we have that mouth movements have quite limited effects. And in particular, we see here that it does interact with gesture, such that when there is no representational gesture, then it does matter if the mouth is providing useful information or not. However, when there are representational gesture, there's an opposite effect, which we interpret with respect to needs to share to divide visual attention. Now, bit gestures behave in a slightly different way, which is really interesting. So what we see with respect to bit gestures is that they interact with surprisal in such a way that when words are high in surprisal and they're accompanied by bit gestures, we see that the signal is more negative. Here, in other words, what we see is that bit gesture seem to increase the salient of the specific words. And this is true especially for those words that are less predictable in context. What they seem to be doing is to direct the attention toward a specific word, in this way making it standing out more, which is indexed then by a larger N for 100 effect. Okay, so I think there are three main results that come out from this electrophysiological work that are really important in my mind. So the first one is the centrality of the multimodal cues. So what we see in this work is that the effect of linguistic context is always modulated by the multimodal cues and by all of them. The second key element, in my opinion, is that we see that the weight that is given to each cue at any given moment changes depending upon how informative are the other cues that are present at that time. And we see this with respect to the role of surprisal, that we see is modulated by prosody and gestures, both representational and beats. We saw also this in the role of the mouth informativeness being modulated by prosody and gesture. And finally, although this is a bit more speculative at this point, it also seems that some cues are more important than others. And so we see that prosody seem to interact with more of the other cues than any of the other one. And then we have gesture, and then we have mouth that in this case seem to have a small effect. However, I put a star because first of all, mouth movement may be more important, as I said before, earlier on during the processing. And secondly, our results are strictly dependent upon our choice of measure of mouth informativeness, and this may not be the best one. So, but overall, I also would like to say that we have replicated these results in a new study with longer passages, and we have extended it to L2 speakers. And if you want to hear more about this work, and in particular, this extension and replication, Yet Chang is presenting the work on Tuesday at 11:30. So to wrap up this part of the talk, I'd like to say indeed that the multimodal cues are part and parcel of language processing. They're dynamically integrated along with linguistic cues, and the processing is the result of trades-off across channels, which to me suggests that indeed we should go beyond this distinction between linguistic and non-linguistic processing of verbal versus non-verbal. And actually, perhaps we should also go beyond talking about semantic processing and start talking about semiotic processing and looking at language's visible utterances, like Adam Camden, for example, has suggested some years ago. Also, as a cognitive psychologist myself, I like the fact that this approach makes language processing more similar to processing in other domains of cognition. So in this case specifically, we see that language processing can be nearly considered as a problem of dynamic cue integration. Similar, for example, to depth perception, where also we have multiple cues, binocular information, we have texture and so forth. And moment by moment, these are integrated in the best way for the best result. Wrapping up the talk as a whole, I hope I'll convince you and show you that indeed these multiple cues are indeed available in the input to children and therefore can support language learning, and they affect language comprehension. And that indeed processing here is the result of trades-off across the different channels. There's an elephant in the room, and it's a big one, and I'm totally aware of it. Learners or the listener is not passive, but clearly active. What our work has done so far is only characterizing the input. And we are starting and looking at the learner and listener as well, because of course the broader goal is to capture the interaction. So moving back, let me make a couple of remarks with respect to the broader ecological language approach. I think, so I have been someone who has been using a very strict reductionist approach to the study of language. And I do think it has great value. But I think the work that we started doing, as well as work done by others in this broader, from this broader perspective, is that this reductionist approach, first of all, can miss the broader picture. For example, vocabulary learning perhaps has far more support from communicative context than what we have been thinking about. I think it can also be misleading. In fact, for example, the impact of prior linguistic context in language processing might have been overrated in past work just because multimodal cues were not there. And more provocatively, it leads also to question some core assumptions, like whether there is a core language network in the brain. Of course, taking an ecological approach means that we need to shift the way in which we do science and the way in which we look at language. And we need to do it in such a way that we can actually bring the lab in the real world, or otherwise the real world into the lab. And I think that the technology is getting in there. So the times are just ripe to take such an approach. And here's a snapshot of one of my lab meetings not very long ago. And on this picture, I'd like to thank you all for your attention for these hours. And I'm done. And I stop sharing, I assume.
Wonderful. Thank you so much, Gabriella. That was absolutely fantastic. Really fascinating work. Okay, so we have about 10 minutes actually for questions before we go into the coffee breaks session. So I'm going to start things off with one question that I've prepared, and then I'm going to select questions from things that I've seen on Hoover and in the chat. So you mentioned at one point, I mean, there's such rich data, but at one point you mentioned with the naturalistic data, with the interactions that you observed, that iconic prosody was not much used. And I was curious about that because I guess that depends on how one classifies iconic prosody, and that's, I imagine, is hard. So I wanted to ask you whether you could talk about how you code this data. Yeah.
Right, so with respect to iconic prosody, what we have done is subjective analysis, and We coded iconic prosody as marking direction, as marking speed, as marking size. You need to go to Victor's talk on Wednesday. There were a number of other dimensions, right, related to these. And then we had, Victor in fact went through the video recording, marking every time the iconic prosody was used. And then we had inter-rater, we had another rater, and all the usual way in which you do subjective coding. Mm-hmm. In this way, first of all, when we started looking at the 2 to 3 years old, we thought, there's no point in looking at iconic prosody here. There's none. Okay, and then instead, when we started looking at the older children, I started thinking, you know, maybe this is worth it. Maybe this will show a very clear age trend. And this is what we have seen. I'm not saying that this may not be an exhaustive way to look at iconic prosody at all. We thought that this was a conservative way, useful when you are, in fact, starting from subjective coding. Yeah. We've been looking at other aspects of prosody as well. Like, for example, to what extent, if you take all the labels that are being produced, to what extent do these labels differ with respect to duration when they refer to an unknown object versus a known one, or when they're mentioned for the first time versus subsequent mentions? And there we do see a very clear effect on duration and actually on pitch as well, that these are marked prosodically when they refer to unknown objects more than when they're referring to known objects. Moreover, and I think that this is really interesting, and I'm spoiling a little bit, actually, this is the talk that Jessie Shee will be giving during the conference. We see that the difference between known and unknown per each caregiver in the extent in which they mark the unknown versus the known in prosody makes a difference with respect to whether the children recognize those labels afterwards, because we did a recognition test at the end. So it does matter. Prosody definitely matters, big ways. It's just that in the conservative way in which we defined iconic prosody, it does matter. It's used very clearly when it's useful, but there's not as much of it as I'd like to see.
Ah, that's fascinating. Perfect. So thank you for your answer. And I am going to actually pick a question from the Q&A on Hoover. So because it follows up on what you just said, because you talked about the role of pitch. So one person asked, apologies if I missed this, but why does higher pitch facilitate semantic integration in the processing study? So this person says that I can understand the role of iconic prosody, but I'm not clear on why specifically higher pitch should matter.
Well, it's a marker of newness, right? So, and we know this from quite a bit of previous work, that speaker would mark new information using prosodic markers, one of which is using higher pitch. And this is, or prosodic stress, however one wants to characterize it. And this is why we do see that it does matter. Clearly, words that are less predictable in context are words that are newer, and therefore being marked with prosodic stress will, in a sense, tell the system, you know, this is new, so you need to put more work in integrating it. And this will allow for the system to do it. It's not a very scientific explanation, but.
No, but that's exactly it. So perfect. Thank you. So I'm actually going to combine two questions that I see, which is I have seen a question on, this is Mary Edward asking, have you considered multimodal cues of child caregivers who are bilingual or multilingual? And then there was another question in the Hoover chat on people with hearing or sight impairment. So in general, I guess the question is, what about individual differences with respect to different people?
I think it's a beautiful question. No, we haven't looked at bilinguals or multilinguals so far. But clearly that's a fascinating extension. Individual variability, there is a huge, I mean, if you notice my violin plots, well, there's quite a large individual variability there. So, you know, in a sense, it's actually surprising that you see anything coming out of this work at all. With respect to individuals that are hard of hearing, that also, it's a really interesting extension. What I can say is that in work that I have done with Pamela Pernis, that in a sense was pilot work to the Ecolang corpus, we have looked at sign language, and we have looked at how caregivers change their signing when they imagine to talk to their children about objects that are present or absent. And interestingly there, what we did see is that caregivers tend to introduce modifications that are compatible with child-directed language in their signing of iconic signs in particular. So for example, they would show an enlargement of the movement of a sign for driving. They would also use non-manual more often, like going with the, in a way that indeed I think is very compatible with what we see here in spoken languages. In fact, I think it's the same thing, just in a different linguistic modality, that caregivers are using these multimodal cues, and they are using them more often when they are most useful to the child.
Great, thank you. Okay, perfect. We are nearly running out of time, but I'm going to ask one last question from the chat. This is Joseph Suzuki Parker asking, thank you for your presentation. You mentioned at the end of your talk that there may not be a core language network. And the question then is, what is the alternative to this according to what you have presented today? It's a big question.
Well, I think you should come to one of my talks, and in particular to one of my collaborators, Jeremy Skipper's talk in 10 years' time. Then probably we'll know better. I think, I mean, there's a sense in which these different cues are processed in subnetworks that are not necessarily the perisylvian regions to the left that we are accustomed to as part of the core language network. And these subnetworks are clearly very strongly integrated with whatever it is in the perisylvian areas that is key. Mm-hmm. How this interaction is going to be characterized? Well, in order to answer that question, we just need to do a lot of work with naturalistic stimuli. I think the field is moving in that direction. There are some amazing, there's amazing work that is being done. So, but it's a little early. But I can still kind of try to provoke a bit of a debate by raising that question, isn't it?
Well, yeah, I mean, that's exciting. There's a lot to be found out then. So with that, before we just briefly give a round of applause in our homes, but I just wanted to briefly say that there were some more questions in the Zoom chat, and sorry that if we didn't get to them. Remember that the questions in the Zoom chat won't actually stay there. So I think you asked some fascinating questions. Please post them on the Hoover Q&A board. And Gabriella, if you find the time at some point.
Yeah, I'll be delighted to answer. So just move them so that I can.
Yeah, and I think people would be fascinated to read your answers there. Okay, with this in mind then, let's clap. Woo! Everybody, yay!
Thank you.
Thank you so much. Thank you.